So thanks for everybody. Good afternoon. Let me introduce myself. I'm Wilson Guo, from the Inspur. So I want to take about 20 minutes to talk about our OpenRMC architecture and our plan to implement on a reference system. So, sorry. Okay, so this is the agenda. So briefly, we will two parts. Firstly, we want to talk about the hardware architecture, how we connect through the networking, IPMI together. Secondly, we're talking about the software, how we implement the southbound and northbound together. So that's our key message we want to deliver. Any questions? If you want to ask, just interrupt me. So this page we're talking about, Inspur as one of the key members. We are co-chairing with Intel to lead the sub-project we call OpenRMC, which one of the projects under the hardware management of OCP organization. Beginning from July of 2019, we contribute our source code to the community, and we are, authorized as the owner for the northbound API definition. Also, we, collaborate with other vendors who are authorized as the southbound API vendor who define the API of the southbound. And also, from here you can see we already released one of the API spec just this month. And after several rounds of review with the core members of the organization. And also you can refer to the codec through the GitHub. I will have the hyperlink in the following pages. So this is the hardware architecture. You can see very simple and easy to connect. So there's the server nodes, which could be every vendors, and also there will be the power supply and the toggle switch. So the power supply could be connect with each of the node through the cable, and which one could integrate the rack management controller, and this rack management controller could be connect through the Ethernet to the toggle switch. And the toggle switch could be routed to one standalone server management node, which can be could connect through the data center. So this is the hardware connection. So so in this way, you can see that not only the Inspur's own server nodes, but also the third parties power supply and the toggle switch need to be work together. So we need to have one common API to communicate with each other. So this is the RMC diagram. So we have the adopt the 8-speed AST 2500 management processor. You can see which can have the bootloader SoC function. Also, the running at 800 megahertz. Sorry. Also, this OpenRMC can support the IPMI and also the redfish. This is the standard specification. Also, based on the redfish, we can develop the web UI, which can be interconnect through the web servers, which are serving the rack management controller. So this is the key hardware component which we used for the RMC. Here, that could be, connect with the second page of my slides. You can see that well, each server node there has a BMC, right? The BMC could connect through the Ethernet to the switch, tau switch. Also, the switch can connect with the power supply. The power supply accommodate one rack management controller. So that means that the whole rack could be connected together, and the information could be collected through the remote server node, which could be a management node. So this is very simple and easy to understand. And also, this is the physical connection. You can see here that there's the tau switch. Each node, the BMC could connect to the switch through the Ethernet network, which is the in-band network. Also, the RMC connect with the power supply from each node, so from the PM bus. So that will be used for the power supply management. And the whole rack could be connected through the to other racks to cover the whole data center if possible. So that's the physical connection for the RMC diagram. And this talking about the software architecture. So based on the physical connection, we have the web server for the RMC, and this is the southbound. So the BMC will communicate through the Rafish spec, and to collect the information from each server node and fitting into the RMC web server. And the web server, it could be serving as the rack management controllers services, and which through the Rafish there will be a web UI could use to present the information on the UI user interface. So this is the software diagram. And we have some changes. Before this version, we use the desktop bus. So currently, we use the Rafish instead of the D bus. So this is the southbound modification. Also in the northbound, we exceed the limitation to several individual server nodes. So in the whole rack, currently about 20 server nodes could be the information could be collected, and in other words could be managed through the whole rack OpenRMC solution. So this is the two improvement at this current version of the OpenRMC. And so you can refer to the link here. Is public. It's at GitHub. We can have the OpenBMC codec. Also, this is for the RMC web server. This is the pulling the information as the RMC web UI. So this reference code public. You can refer to that and download if you want to have some access. And the RMC web server, currently we support the Rafish version 1.6 and use the C++ library. So the library also could be accessed through this hyperlink in GitHub. Also, we have several reference code you can see here. So it's very easy to obtain the data through the BMC, which we use the refuge specification. So this is a sample code. You can refer to that. It's valid. Also, this page we are talking about how we can demo to build up the OpenRMC image. So firstly, you can download the code from the website. So secondly, you need to build based on the hardware. So according to the environment variable, so this very typical template config, which is one common command. And also you can see here the meta dash Inspur is one of the specific Inspur hardware environment. So you need to build up to the Inspur hardware environment so that this code could be a work. And also, after that, you can build up your image. So this is very simple. You need to refer to Inspur's hardware reference system so that this code could work. And also, this is the web UI. We have the very simple but direct information through the web UI. You can reference that and build up to collect the information to build up the web UI. So this is the refuge tool, which could be used to collect the information from each node, and could be used as the management solution. And last but not least, I want to talk about our open system firmware roadmap. Currently, we are at this stage. So we can see that we already released the northbound API 1.0 to the community. But this is not enough. So we want to release one complete rack reference system so that you can not only have the code but also has the reference system which could be used as a live demo. The customers or the vendors, they can use as a reference system not only to access the code but also try to evaluate the solutions through the hardware system together. We think we're looking forward to next year's maybe in San Jose, the OCP summit in March. So that will be our target. And last, we welcome that you access our code from the GitHub and try to evaluate, give us some feedback. So we think that this management solution could cannot be achieved without every vendor's contribution and participation. So if you have any good idea, we are open to discuss together. So that's my slides. Any questions?
Thank you. So OpenRMC is an aggregation layer, let me say. What happens when a node, which is already Redfish compliant, OpenBMC, for example, is the OpenRMC view, is it a duplication, a replication of what we can already see directly when acceding to the OpenBMC of the node, or is it a different view?
Currently, we build up the OpenRMC based on the OpenBMC information collected through each node. So it's kind of a duplication from
It's a duplication.
Node. Yes.
Okay. And what about the other nodes, like IPMI nodes? Do you deduce in the OpenRMC layer the JSON representing the IPMI node? Is that right?
Yes. If as long as it's the based on the Redfish spec, we can apply the Redfish command to collect the information from the node, which is independent to the server vendors.
Okay. Thanks.
What about using OpenRMC to collect data from nodes which don't have any BMC? For example, some servers come without BMC, which reduces security nightmares there. So having one centralized solution to collect all the data from nodes without BMC, is that also something which OpenRMC could do in the future, maybe?
So that's a OpenRMC southbound requirements question. So on the top layer of OpenRMC, it's Redfish. On the bottom layer, if you saw my diagram, it was Redfish. It could be IPMI. It could be whatever you want in order to get that data. And what the RMC interface does is actually transforms that data so that you only need one interface to access all these different types of platforms.
Thank you.
I got to ask a question on the decision to use the 2500. Is that still your? I noticed the AST 2500 in there. Is that still kind of what you're planning to do?
Yes. Currently, we use the hardware as still the 2500.
That's been known to be slightly problematical with respect to some of its security. I was looking up some of the CVEs around it, so I was just wondering. Like do you know about the baked-in password in the mask ROM on that machine?
Your information is I need to check with my teams.
Okay.
Yeah.
Yeah.
So
I think you should take a careful look. I've been told that 2600 is a better choice.
Okay.
So.
Okay.
Right.
Good. Thank you.
Any other?
You mentioned that you based OpenRMC on OpenBMC. How far are you making progress, or are you planning to make sure that this is eventually also part of upstream OpenBMC? Do you think that will happen? So that OpenRMC is just, so nobody has to clone from your repo, but just can use the upstream OpenBMC repo and use that for OpenRMC. Would that be possible?
Sorry, so you mean the OpenBMC and OpenRMC, the workflow could be easy to implement? Is that your question?
More like if it's an OpenBMC fork right now, is there a chance that it will be maybe folded back into OpenBMC as part of a specific profile from OpenBMC, so people can work together, have some common ground and not just be a fork?
You know, currently we have the reference code. I think I need to talk with my engineering team to give you the clear answer. But currently we think this is the since we need to have the one open management architecture. So this is the feasible way for us to implement that. Others will be the preparatory solution. So this one is still the most feasible way to have that.
I think it's really good that it's based on OpenBMC. That gives you a common code that helps. Thanks.
Thank you.
Further questions? Thank our speaker.
Thank you.